this month's TMS Tuesday is a review of how we apply 21st century technology to airfield lighting applications. A fascinating topic which Tony Smith has kindly agreed to share his knowledge and experience of a lifetime in the industry to explore what some potential areas, and to provoke some thought to whatever your interest as an airport, a designer, a consultant, an installer, whoever you are. I think you'll find something in this for you. Our webinar team is, of course, Tony Smith, the world-renowned inventor of the PAPI and all over airfield lighting specialist with a lifetime working in research for the UK government as a government scientist. Stuart Ford is representing us from the as having worked in the airfield lighting industry for much of his career, and then becoming with Klaus Heinz and becoming an independent trainer and consultant thereafter, and still highly active in working and influencing the future regulatory environment and helping airports. Carl Johnson, senior aviation specialist with Avcon Inc., over 50 years design and construction experience working with maintenance and electrical systems. Again, now working on very much with training as well as consultancy, and extremely knowledgeable in all the key areas of airfield lighting. Keith Costel, director of TMS Training Solutions. He's an independent consulting engineer with a lifetime working in airfield lighting, originally working with the Navy, but in the UK, but then many years in particular heading up the customer services operations for ADB, Safegate. And so without any further ado, my name is Robert Shapton, Managing Director of MARMS. We will kick off, and I introduce to you Tony Smith for today's presentation, applying 21st century technology to AGL applications. Over to you, Tony.
It's good to be able to be speaking to you today on this subject. I hope you will find it interesting. It's a very personal view. You will probably in the discussion have contributions you want to make, and that will be valuable. But it does seem to me, when we were thinking about what might be a suitable topic for today, that it might be a time to review where we are. There's technology is always on the move, and are we making the best use of the technology that is around in the AGL world? Applying 21st century technology to AGL applications, it's my personal review of some of the things we might take benefit from of the way things have moved on. Because as an industry, surely we're always seeking to be providing best practice in what we do. And that raises a question immediately in my mind. Are the grandfather rights that we all inherit still the best? And by grandfather rights, I mean those things that have been there for years, and because they've been there for years, of course, they're the best solution, and they're suitable, and they're safe, and that's what we want. Our grandfather rights carried forward into this new millennium, even the right place to be. And if you like, ask a question that would sort of highlight what I'm asking is, are you driving a car that was designed 50 years ago? Just think about that. There aren't many things in and around our lives that were in the same design and the same engineering 50 years ago. But in ground lighting, I believe there's so much that goes back that far. So let's move on to the next slide. And so some questions that come to mind to facilitate our thinking this afternoon. Is today's best practice really taking advantage of the technology developments that have happened over the last 50 years, or is AGL provision in its widest sense, still dominated by the technology solutions available 50 years ago. They reflect, is that what we're seeing if we pick up an Annex 14 or an aerodrome design manual? Are we really looking at stuff that was there 50 years ago, unchanged, ignoring the march of technology? And having said that, well, can we improve operational performance standards by using more recently developed technologies? I think a relevant question. And as a subset of that, can equipment design and performance be improved by adopting new technologies? Also, if we adopt new technology, do we really see the potential of improving maintenance levels, which is the foundation of these TMS webinars, really? We're talking about the ability to improve maintenance levels, which surely are needed to. It is a thing that needs to be improved and needs to be worked on constantly. The important one, particularly if cost is in your mind, will AGL costs be reduced if we adopt newer technologies to provide and meet the specifications that are there for the various elements of the AGL? And will, in fact, as a result of this, will we improve safety? Safety is absolutely foundational in the industry, and if there's an opportunity to get a safety enhancement, should we not be adopting the technology that will enable us to do that? And also importantly, and very much in mind in this day and age, are there environmental improvements that we'll get by adopting new technology? Shall we help with the drive to net zero carbon and all that by adopting the new technology? We have that in mind as well. So let's say, well, if some of the answers to those questions are yes, what are the technologies that we might be looking at? And I wouldn't say for a moment this is a totally exhaustive list, but it's an idea of some things that I think come readily to mind. One are the new light sources which are available, which replace the tungsten, which was the main source 50 years ago, although there were some discharge lights at that point, so-called the sodiums. Some of you, if you're old as I am, remember sodiums, which were the early attempt at high intensity lighting. We don't use those anymore. We're not using tungsten really. That's going, and discharge sources. There are issues with discharge sources, which I'll highlight a bit more. Can we, in lots of cases, get the required signal without using a discharge source? Can we improve the light characteristics, what the pilot sees in terms of the color stability, the color he or she recognizes? And can we get benefit from longer life from new light sources that are touted by the manufacturers as being significant? Can we really take the best benefit from that? Can we improve the light sources we use for non-point source lighting? And I mean by this particularly signs and floodlighting. Are the benefits for making the switch? You probably have to do it anyway. Are there some benefits? Do we make the most, the best use of the new technology? And then there's a matter that impinges on safety. Can we have less ambiguous visual signals? I'll say more of that as we go through this presentation. It's a human factors issue, the things where things can go wrong because visual signals are misinterpreted. Can we reduce the possibility of that occurring in various ways? And then, as a feedback from what we've been hearing in previous webinars, enhanced PAPI specification. I personally, and you perhaps expect this from me, I think the PAPI specification in the documentation in Annex 14 as the source, does need enhancement. It needs so that we get improved equipment compliance. What is being seen is that the equipment that's out there that truly doesn't meet the specification, but it probably needs more specification documentation to really tie down this specification. So what you as the end user of aerodromes, you get what is truly a PAPI equipment. And then I mentioned mathematical modeling and simulation. This certainly is something that wasn't there 50 years ago. With modern computing techniques, you can mathematically model what pilots will see from the lighting you are proposing to use. If you're proposing to change beam spreads or patterns, you can model, and you can actually produce mathematical results of that, but you can also feed this into simulation. You can have simulations with pilots flying the actual system, and you can change and improve lighting patterns and indeed produce new systems if there's a requirement. And I'll speak a bit more about that later on. And then, of course, take benefit again of the advances in technology for in-field measurement of AGL. 50 years ago, there was no real means of actually doing a meaningful measurement of the AGL output. Standards compliance is very important actually in our field, and 50 years ago there was very little attention paid to this, but now the technology highlighted, if you like, by what AGL, what TMS have on the market, perfectly practical systems for doing that job and doing it well. And finally, I've thrown in an area that certainly isn't my area of expertise, but power systems. Can we get greater reliability and more appropriate systems of power distribution for LED lighting systems to get improve safety and the fail-safe of power systems and so on? I want to say a bit more about that. I think that can be addressed. So let's move on now to the first of these areas, which is the light-emitting diode. We all know it's replacing rapidly, if not totally, tungsten sources for our lighting. Its commercial pressures are dictating this, so that AGL has no option but to adopt and adapt. Nobody is going to make you a few thousand tungsten source lights just for your aerodrome. It's not viable. We're going to have to live with LEDs that when they came on the market were marketed as just a magnificent step forward with no shortcomings and problems. However, straightforward one-for-one replacement is not what's happening at the moment. There's more development work needed to fully maintain and get the benefits from LED. I maintain there's more work to do in that area. Again, a bit more later on. One thing LED does offer, of course, is good light signal colors. Very important in visual signaling. Not only the patterns, but the colors have meaning, and we can improve the chances of the wrong colors, perhaps by turning brightness down. We can avoid those sorts of issues with LED. I put it to you that also LED is a technology where you can make very effective flashing devices, and you don't have to use mechanical occulting devices, rotating mirrors, or in fact use, I think in many cases, discharge sources, which have their issues, not least in specifying them in a reliable way and being assured you're getting the output you want. LED can be applied to overcome some of those issues and improve that area of AGL. And finally, the point there about LEDs being, as it were, virtually impervious to actually ambient temperature. Very different from fluorescent tubes. I was looking up recently in the IS book on lighting, very comprehensive, and it talks about large variations that you can get in fluorescent tube output depending on ambient temperature. Fluorescent tubes generally designed to operate indoors in an environment, shall we say, of 20 degrees C. If you go to 0 degrees C or -10, depending a little bit on which fluorescent tube you use, you can have a light loss as much as 5 to 1. So, for example, in signage, if you're using LED tubes out on the aerodrome, they could be quite dim in low temperature conditions. We could avoid using fluorescent tubes for that sort of application. That's a potential benefit from LEDs. So we're going to carry on to the next thing to consider. We move on to the next. Perhaps at the moment, we've been talking very much about, in reality, about point source lights. But of course, there's a whole area in AGL which aren't point source lights, like the runway center line or approach lighting. These are things like signs and floodlights, where surely there's an opportunity to take benefit of LED lighting. Already see this has had application in signage, putting distributed arrays of LED. But the examples I've seen, there's still some design and development work, I think, to be done to make that work properly, to get true uniformity. There are signs which are LED illuminated, but they don't comply with the Annex 14 requirements. But surely there's the possibility of some engineering development work to get truly uniform illumination. And then there's the matter of daylight visible signs. In other parts of the world, our everyday life, we see these everywhere. We see them on hoardings, advertising out in the streets. We see them enormous screens at sports venues. And if one thinks of the soccer environment and that sort of sport, where there's a pitch, we've got what used to be sign boards around the edge advertising. That's all done with daylight visible signs now. The luminances are visible in all conditions. 20 years ago, I would love to have had a technology that could do that. I could see all sorts of applications in and around aerodromes where signs that could be used day and night would be of great benefit. And we could enhance the signage in low visibilities by adopting this technology, getting away from producing effectively a light box which shines through a face plate. Of course, the faceplate is visible in daylight, whether you want it to be visible or not. Whereas, of course, this signage, if you don't want it, you can switch it off. And I do want to say a bit more about that later. And of course, with when you start to think about advanced surface movement guidance and control systems, follow the greens and the taxiway lighting. But with that, you can also use that technology, I believe, if we did a study to enhance these signs that we now have and make them more variable message signs. The sign could be used for, if you like, possibly potentially adding to safety, particularly in areas of runway incursions. More on that and on. And then LED floodlighting, because you can get LED that produces very good color rendering. This is a potential in servicing functions on aprons, for example, where there are operations that the ground staff have to do, where the identification of color is important. And so the LED floodlights would seem to me to be a way that we're probably going to go. And it'd be a good thing to adopt that with a certain amount of glee and satisfaction that we can have that. So let's move on then to my next set of thoughts. Again, about less ambiguous signals. I think I can say the concept of the ring of red, which many of you are aware of. I think I was the first person to use this phrase in an ICAO visual aids panel back in the 1980s, early 90s, when we were standardizing the signage system, the one you see worldwide nowadays, the red, white, and the yellow, black signs, mandatory, and the information signs. The ring of red concept was a response, if you like, a goal to help reduce the number of runway incursions, in spite of all the signage that we then had, and all the volumes of what pilots are supposed to do. It is a problem. It's runway incursions, active runways, pilots and vehicles going onto active runways without the clearances they need. And sometimes the possibility is there, and we can, with the new signage I'm talking about, we can plug the gap where because all the signs are legible in daytime, not that they're lit in the daytime, but in daytime, all the signs, whether you like it or not, are visible to the pilot. At night, they're all, in practice, they're all lit, but you could selectively switch ones off that aren't relevant. That would be an enhancement, and again, say a little bit more about that later. Because we can see the signage in the daytime, just the face of the sign, we can see that, and we rely on that, and it's only what the ambient light provides gives us a brightness for them. That's a potentially dangerous human factors breach there. It's there all the time, and there are examples of people taxiing past mandatory signs when they shouldn't, but also the other way around, human factors. If you're, for example, taxiing in Cat 1 operations, there'll probably be category 2 and 3 signs further back from the taxiway runway intersection. Now, you're only operating category 1. We all know we're operating category 1. So I drive past a red sign that we've said on the ring of red concept, you should not pass without getting a clearance. But in fact, implicitly, the pilot ignores it. Now, that is not good human factors. And if we have signs that are lit day and legible day and night, if we're in Cat 1 operations, we can switch off the Cat 2, 3 signs, and that will be an enhancement in safety, surely. So there's potential there by going to the newer technologies to enhance the safety that comes with the signage. Another feature of ambiguous signals is the runway centerline lighting. You remember the centerline lighting is coded to give the pilot some indication he's approaching the stop end of the runway. The last 300 meters of centerline lighting are in fact designated to be red. what was required was something, a sort of warning sign that you're getting towards that part of the runway. What was wanted was a sort of warning code, and at the time when the specifications were written 30 plus years ago, the only way that could practically be done was to alternate red and white signs. Well, you don't want alternating red and white signs, you want yellow signs. And nowadays with LEDs, we can have yellow lights that stay yellow in all conditions, and the white lights that make up most of the runway lighting will stay white at all times, no matter what the intensities is. So we do have a clear color differential on the center line between white lights and yellow lights, and this improves the human factors of that application. Again, a safety enhancement, not difficult to implement, actually, this one, if you think about it. So move on to the enhanced PAPI specification that I mentioned earlier. It's been clear in earlier webinars and inputs from Robert, his practical experience, that all sorts of horrendous examples of bad PAPI implementation are out there on your aerodromes. And thinking about it, I think that there's a basic problem in the specification in Annex 14. It was intended to be as broad as possible to give manufacturers a chance to have some initiative in their designs. But I think on reflection, it isn't specific enough. And designs don't need to be complex, but they do need to properly comply with some basic specifications. And I think with the introduction of LED, this has been increasingly highlighted with, if you like, third and fourth generation PAPIs being designed by people who don't perhaps have the background and the operational understanding of LEDs. Not for a moment saying they're not good designers of operation of optical projection systems, but I think perhaps they're missing some of the very fundamentals that have to be built in. First of all, we learned this in our development work. You do want the lenses, the filters, and the light sources to be part of one structure, inflexible, immovable, that basically they're all in a constant and immovable relationship one with another, all related to a rigid base in your design of the box of the PAPI. The second thing, which I think there is some confusion about, PAPI signal is essentially a sharp transition from one state of color and intensity to another. It is this sharp transition which, in practical terms, appears to the pilot to be instantaneous. It flicks like a switch, like a light which is, you're using on an obstacle or something. It is a flash of intensity and color. That sharp transition is critical to the PAPI achieving what it is purported to achieve. And so your image must be at infinity, not at some intermediate distance of a few tens of meters or something. It has to be focused at infinity. And to achieve that focus, the filter, the object that's being projected, if you like, must be precisely located in the focal plane of the lens. Lenses, it isn't difficult if it isn't actually given by the manufacturers to find out the focal length of the lens, and that's where at that distance is where your filter must be if you're going to have an infinity focus. Another thing is that we've found that where you have multi-lamp ways in a particular projection box, 2 or 3, in one box to achieve the intensity and beam spread and so on. That's a standard way of designing a PAPI. Each one of those lampways might well meet the sharp transition requirements of less than 3 minutes of arc, preferably no more than 1.5 to 2 minutes of arc. All very feasible and possible. We showed this in our basic research. But all three in the one unit must be set, if you like, that transition must be at exactly the same angle. Otherwise, if they're distributed, and I've seen photographs where if you look across the box, the transition gets lower and lower as you go across the three boxes. This is the eyelid effect, which you can view at short ranges. You should be able to view the unit for a few meters, and by bobbing up and down, see that the colour in all three changes at exactly the same place. Another thing that I want to stress is that, and I think it's sometimes ignored, it's said that PAPI is a red-white signal. It is a red-white signal. That is key to the design. It's only one of those two colours, red or white. The transition so quick. It is a red signal or it is a white signal. No ambiguity about that. Easily identifiable. But the ratio when you go from red to white in the original design was at least 5 to 1, because we were using a tungsten filament and a dyed in the mass glass filter. That results in about 15% transmission in the red sector. You get 5 to 1. And we recognized and realized, but we never wrote it down, that change of intensity as you change color was an important contribution to the conspicuity of the transition. So this is an area where someone designing this PAPI today might say, well, now I can use LEDs and I can design it in such a way I can match the red and the white intensities. Sorry, wrong. You should have, well, if not 5 to 1, at least 3, 4 to 1 to get this thing that looks like a very sharp switch of intensity, like you get on an obstacle light, which is switching on and off. And your PAPI must be designed such that you can measure the vertical, horizontal setting angles for both for maintenance, but also for initial installation. You must be able to be sure where the optics, if you like, are pointing. You need. We actually had on the edge, on the side of the base, we had plates so that we could put an inclinometer on there, a very accurate inclinometer, so that we could align the units. And we never had any trouble all through 10 years of testing with that as a means of setting up. But it is important that you have that. And with that, the inclinometer you're going to use must be regularly calibrated. Whether, as I say, it's a device that you bring to the box and put onto a plate, or whether it's a built-in, as I've seen. I know there are designs where an inclinometer, an electronic, as it were, inclinometer is built in. How accurate is that inclinometer, and how frequently is it calibrated? You need to ask that question. It needs to live in a world where you're measuring setting angles to an accuracy of a minute of arc regularly and repeatably. Is your inclinometer up to that? So just to illustrate a couple of things I'll say. Sharp transition, focus. Now, this is a diagram. I remember first counting it. I suppose I was a schoolboy, about 13 or 14, in a physics lecture. This really is schoolboy stuff. But I just have this feeling that there are people out there designing PAPIs who perhaps either have never come across this, which I find hard to believe, or forgetting it. Here's the basics of a projection system. The left-hand side, there is that red arrow represents, if you like, the red filter. And then the light is projected through the lens. And at some point, there is an image, an in-focus image generated. Now, that sort of geometry you'll be familiar with projectors, the old 35mm slide projector, or today with your projector that goes along with your computing system in your conference room. You adjust the distance between the lens and what you're trying to project to produce an image which is in focus at the distance you want it, whether that's on a screen which is 10 meters away from your projector or wherever it is. But for the PAPI, the image is supposed to be in focus at infinity. Now, how do you achieve that? It's really very, very simple. You need to know the focal length of the lens, and your object, your filter, needs to be co-located nearer to the lens than in this diagram, at the distance equal to f, the focal length of the lens. You put what you're projecting at the focus of the lens, and then the image will be in focus at infinity, and in practice at all ranges down to a very short distance of 100 or 200 meters. Probably you won't see anything other than very sharp transition. But in the design, it has to be focused to infinity. And if you say, well, how can I check this? Well, you don't need a lot of equipment to do it. I would suggest, if you want to know, is this really a PAPI system, apart from looking at the eyelids I was talking about a few minutes ago, ask the manufacturer to illuminate one of these units at one end of your airfield, go to the other end of the airfield, find out where the transition is, and just bob up and down. And between standing up and bobbing down, over 3 or 4 feet, you should see a complete color change. Then you'll know you've got a PAPI that is focused infinity and is actually truly a PAPI system. During development work, we did have people from different companies came along, and we did this test. We had a range of 2 miles, 3 kilometers, which was very accurately measured with theodolite. Actually, we knew exactly where we could go to that position, project their PAPI, and see if they got a sharp transition. And there is some material in the aerodrome design manual about you can put a reference light alongside, which is a red or a white, and enhance the signal. But basically, just bobbing up and down at a distance of 2 miles or 3 kilometers, you'll be absolutely certain that you've got a sharp transition, if is what you see is a very rapid click from one state to the other. So there's the basic physics, schoolboy physics, but I suspect from what I'm hearing in some places, it's not being implemented. So let's go on to the other slide I wanted in this area. There, what I was talking about. On the left-hand side, L1, 2, L3, those are 3 lampways in one box. Each transition probably meeting the better than 3 minutes of arc, but not actually aligned one with another across the box at a slightly lower angle. The end result is the diagram on the right, L1 plus L2, L3, where you've now introduced what is effectively a pink zone. So if you are at an aerodrome where the pilots say the PAPIs have got a pink zone in them, sorry, you've got a non-compliant PAPI unit there. And what I'm saying here is probably giving a good hint as to where you might find a solution to your problem, assuming that each lampway in fact meets the criteria of not more than 3 minutes of arc, preferably less. So we've had that reported and seen it in a number of cases. There, I think, is an answer to Now, using the technology properly, you should never have a pink zone in your PAPI. There's nothing you can ever see and classify it as a pink zone. So let's move on to my next point, the mathematical modeling. I already mentioned this. We developed programs to do this. They're referred to in the aerodrome design manual part 4, where we could model mathematically what a pilot would see during an approach to a runway, for example. You need to put into it the characteristics of the fog, which we knew about. It tends to increase in density with height. That data is available, so you can put different types of fog in. You know the characteristics of the lights you're using. You can feed those in. Each light in the system, you put in its beam spreads and its setting angles, and then you compute an approach to that lighting, and out of that comes, if you like, a diagram that shows what you see at what height in that particular fog. And you can change the fog, you can change the lighting and change the setting angles on the lighting. You can do all sorts of things with it. But it helped us 20 years ago to really understand the relationship between fog characteristics and lighting. It's a very powerful tool, and it can be used to set up simulations now. And so in trying to design new lighting systems, you can use this to computer model it and put it on the visual base of a simulator and actually fly it with the pilots, and you check that it does what it says it does. Far cheaper than what we had to do 40 years ago. Literally make the equipment, install it in the runway, and then go flying at very great cost. You can use this technology to develop a new requirement. And I can give you one example. It's when we'd done this fairly early on in the UK, there was an airport going to be built right in the city of London in the dock area with a 6-degree approach, and the requirement put on the lighting provider was to provide the lighting for a 6-degree approach. Now, how do we do that? They got no idea. The CAA just said this is a requirement. They came to us. We modeled it. We used existing lighting specifications for practical reasons, but of course we changed setting angles, and we optimized it using this program. So we got a lighting design which would support category 1 and indeed into category 2 approaches into that runway at 6-degree approaches. So it has very practical applications, and it's a great tool going forward that you can use to optimize your whole of your lighting design. There's both beam spreads and patterns and so on. And for example, another use of this, we did quite a lot of work in a simulator, reducing the number of lights in the existing lighting patterns to cut down the cost of maintenance. You'll find it in Annex 14. It's dependent on you having lighting that does meet the requirement and demonstrate the requirement. You can significantly reduce the number of lights to produce, for example, the touchdown zone lighting and so on. So it's a very powerful way of going forward in developing new lighting systems. So let's go on from that, which I think is a very powerful tool for the future. And it works now. Let's go on to the next consideration, having talked about mathematical modeling. Very important matter of in-field performance. Nothing more dangerous than ignorance in action. I had a boss years ago who liked quoting that, in a safety environment that aviation is. It was the German philosopher Goethe that actually said that originally. There's nothing more dangerous than ignorance in action. That was actually the situation we had in AGL in the 1970s. When I was working, actually we were developing high-intensity taxiway lighting at that point. That's what I was involved in. And I made measurements at airports, international airports, which were approved, said they met the operational requirements because it had a flight test. No, they didn't. There were places where the centerline lighting was only 10% of what it should be, but within a week, last week or so, it had a flight test and was deemed to be serviceable. Well, unless you actually measure intensity, beam spread, setting angles, and color, you cannot know that you're meeting performance. Flight tests are of little value. If you want to go flying and see that you get 5 stages of brilliancy when you ask for it, well, I think there are cheaper ways of doing that. A flight test, if I could, I would ban flight tests as being usable for verifying any lighting systems. So in the 1990s, we did some R&D in my team, and we showed that such in-field measurements could be made. And at that point, the CAA then put a project to what is now TMS to develop that. And I monitored that work as a technical monitor. And the great thing about that is that not only do you get the data that the maintenance people can see, but you can store it, you can analyze it, you can use it to set up your maintenance schedules. You know what you're dealing with. And what we saw out of that, we used one of the international airports in the UK as a test bed. After a period of 6 or 12 months, you could see the lighting was fully compliant. It hadn't been before. It could be kept compliant, actually, because you knew what needed to be done and when. It actually reduced the amount of costs, both in what was procured and replaced, and also the hours required to do it. So costs went down and performance went up to the required levels. So there's nothing more important in many ways than having this in-field maintenance measurements done by a method that is practicable when you're working on a busy airfield, probably. What I said about generally applying to thinking of approach very much applies to PAPI as well. You can't check PAPI, I maintain, by a flight check. One technique that's used is fly through the PAPI system at a height of 500 feet. Well, I put it to you, if you fly through at 500 feet, you can't fly an aeroplane to manually, certainly, to maintain a height of 500 feet. There'll be variations at the very least of 10 feet, more like 20 feet, as you gently go up and down around them. Well, a 10-foot height error in that fly through actually will result in 2 minutes of arc error reported in the PAPI. Assuming it's a sharp transition PAPI, of course, you'll say there's a 2-minute error. Or if you delay, in other words, you have a stopwatch which you click when you go through the PAPI, and you know where you are. If that measurement is delayed by a second, you'll also get typically a 2-minute of arc error. So cumulative errors, you'd be lucky to be within 5, even 10 minutes of arc of the right place, I would maintain, by flight check. Don't do it. You use a properly designed system, ground measurements to do it, and then you'll actually be compliant. So let's go on now to power supplies, really getting towards the end. This is an area which I've thrown in slightly tongue-in-cheek, because power distribution, and it is not my specialization, but what I would say is, here's a classic example. I think if you look at the Aerodrome Design Manual Part 5, here is 1940s technology shouting at you, saying, here I am, I've been like this forever, and I can't and I won't ever change. We do need to think about, I think time has come, we've really got to bite on that bullet to have power supplies that are properly matched. And Seward was telling me about some trials he did about 10 or more years ago, which are actually very successful, to have a proper power supply supplying LEDs. But that isn't really being addressed at the moment. So we're getting units that are manufacturer unique, and you can't interchange. You can't take a centerline light fitting from one manufacturer and replace it with another, because there is involved some electronics which particular to that manufacturer. So we should be able to do what we can do now with LED, and that is simply replace the light source, as it were, readily from commercial stock, and not have the electronics in the circuit at all. And I say that with some confidence, because in my house I've got a lot now of LED lights, which are a direct one-to-one replacement for the tungsten halogens. There's no electronics involved in the and I can dim them. This is in a standard light bulb. Surely we ought to be thinking in terms of making all our AGL using standard light sources that are available commercially. And then the last point, modern technology, there's potentials there, and Keith might want to say more about this, about modern technology in terms of what's in the B centers and distribution centers. But this typical thing where a 15-second delay because your standby is a generator, still widespread. That is not really operationally and safety acceptable, because we had a case in this country where an aircraft had made a decision to land, fortunately not in low visibility. He was literally over the threshold when all the lights went out, because the public supply in that part of the country suddenly just failed. Something very, very rare, but it did happen. Fortunately, the aircraft did an overshoot, but you can't afford to have a 15-second delay when you're in the approach phase. And the way we had to overcome that, we got this system, it was the only system available when we went fog flying 30 or more years ago, was we ran flying on the standby generator. We ran that, and so if that failed, then of course we had instant recourse to the public supply. There was a no-break system. There are various ways of doing that, I know, and I know some countries that they've got that. I saw some facilities in Japan many years ago. So effectively, they've got a no-break power supply on sort of critical areas, certainly, of the lighting system. And I think perhaps modern technology could help in implementing that more than it is at the moment. So there we are. I come to my last slide, and just to throw the ball back at you and to say, 30 or 40 years ago, I was in the position, if I saw technology that looked as if it could make an improvement, I could go to the CAA and say, will you support that I do some research to demonstrate this? And they would say yes, and I would do it, and then we could demonstrate that there was indeed an improvement. We've flown against it, we knew how to do it, and we could go to ICAO and recommend some enhancements or changes to the specifications. But that sort of system doesn't remain anywhere. It really is over to you. You're the customer, and you really should be in pole position. You shouldn't have the lighting manufacturers telling you what you want. You should be telling them what you need, and you need to involve, I think, people like pilots as well as the regulators. But you could, and I think you need to perform this function to ask for these things, that are all these various ticks here. You should be asking for that when you you need to be part of the specification writing right at the beginning of any project, and ask the manufacturer to show compliance and how they're going to do it, and to be willing, if they can show that it is beneficial, that they use new technology, and not to be afraid of that and to move forward. So I'll stop there. I think, used up really most of our time together, but I'm sure Robert wants to have some feedback now, and so.
Right. Well, thank you, Tony. Before we get, as usual, we have limited time for questions and answers. Don't feel free to ask more questions, and we can take them offline directly with you. But first of all, just to say on note, their next TMS Tuesday on November 28th, at the same time, we'll be on this. We'll be addressing a very important issue. Whereby airfield lighting maintainers do not have sufficient runway taxiway access to maintain the lights, the signs, and the PAPIs and the floodlighting. This is, of course, critical. As a passenger, as a pilot, you expect those lights to be maintained in a compliant state when you arrive or depart from any airport. There's a quote from the Department of Transport Secretary in the USA of Ray LaHood, who said, we expect operators to perform inspections and conduct regular and required maintenance in order to prevent safety issues. There can be no compromises when it comes to safety. This is I don't think anybody could dispute that. But the fact is that today many airports are not giving sufficient access to airfield lighting maintainers to conduct their maintenance. So this very important topic, we will be giving illustrations of very busy airports that do manage to overcome this problem, and discussing it from the point of view, and I invite regulators, air traffic control, and operations people to join usual audience to participate in that, and we'll be promoting it accordingly. So that's on Tuesday, November 28th. So if I can stop sharing now and come to the panel again, Tony, Seward, Carl, and Keith, who's hiding, and Damon, of course. Today we were discussing, the 21st century technologies in the context of airfield lighting and the opportunities they represent to us. And Tony gave us some illustrations. If I can just come to some questions here to start off, the questions from the audience. I see a couple have been answered. I see Anthony has asked, what is the definition of a sharp transition in the PAPI? Is there a measurement of variance between the filters and the PAPI unit itself? Can you just clarify what the requirements are for sharp transition? Who shall I offer that to? Keith?
Yeah, well, the transition, as Tony explained, the transition between the white and the red, is within a specific arc, which is 3/60ths of 1 degree. That's 3 minutes of arc. So it's like, as Tony has explained in other webinars, it's basically a slide projector. So it's a click scenario, that transition zone. However, when you have more than one light source in a box, in a PAPI unit, then each of those light source channels then need to be aligned. For example, one of the slides which Tony explained in his presentation today demonstrated that if you have a different position associated with that transition zone, then what the pilot will actually see is a widened transition zone, which is commonly called the pink zone. And maybe Tony could come in and just re-emphasize that point.
Yes, that's very, very important. And I think what I'd want to say is, wherever you are in the world, if you feel, if you get comments from pilots that the PAPI isn't sharp and so on, they can see pink zones and so on, you can very easily and very quickly do a test to see if you've got a sharp transition. Yes, you know, you could ask Robert to come with his equipment and manufacture it, you know, come and help you out, and that would be a good thing to do. But you know, if that's put to you by a pilot, within an hour, you can go out on your airfield and you can check whether you've got a sharp transition. You simply need to take the PAPI unit and to turn it so that, you know, to change the setting angle so it's virtually horizontal. I suggest, assuming your runways, your airport's virtually flat, and go to the boundary fence, and preferably to the other end of the airfield. So you're looking at ranges well in excess of 1,000 meters, and literally you'll find the place. You just adjust it. Today with mobile phones, it's easy to talk to somebody at the other end and say, down a bit, down. Oh, now I can see the transition. And you should be able to stand up and see white, and then just crouch down, just bend your knees and see red. If you can't do that, you have not got a compliant PAPI. You don't need any equipment. You just need the Mark 1 eyeball. I suggest you take 2 or 3 people together and agree amongst you that you're all saying the same thing. But that's what we used to do. And in the early development phases, when manufacturers brought their equipment, we put it on a range, which was 3 kilometers, and we'd take them out to the viewing place, and we could show them whether they would sometimes say, oh, we've got a sharp transition. And when we showed it to them, no, they hadn't. Mm. It's very low tech test, but it's absolutely conclusive. And that's what you're then seeing what the pilot should see.
Good. Thank you. I think that's an interesting experiment that I hope many of you will engage in the next few weeks or months. Jamie Andrews asked an interesting question. With the constant advancement of aircraft technologies, do you think the need for a PAPI system will ever be phased out? What do you think about that, gentlemen? Do we think there'll come a time when we don't, because of the technology in aircraft, you will not need a PAPI? Or do you think it'll always be there as a visual aid?
I think that my comment that I've written down is that we have visual flight rules and we have instrument flight rules. And in visual flight rules, then, you know, VFR, then yes, then the PAPI is a mandatory piece of equipment. When you go to the IFR rules and instrument flight rules, and of course we know that we synchronize with the instrument instrument landing system. And then we're moving now towards the GBAS landing systems, etc. So things will potentially change, you know. But there is the difference. It's VFR, IFR.
Right.
Exactly.
Maybe Stuart or
no, I think that's
Carl
right.
would have some view on this.
Oh, I think he hit the nail right on the head.
Yep. Right. Carl and Stuart, I've got a question here from Mohammed Azjad, who's asking about standby generators. Which Tony talked about earlier. What options are available, and how do US airports handle the situation of generator public electric service switchover in the event of an issue? What are the options, and how do they do it in the USA?
Carl, you can handle that one.
Yep, in the US they'll have a generator and a utility service, and in bad weather it would be like Tony was saying, that they'll fire off the generator, run the lighting off the generator, so that they can transfer back the utility source in the half second, whatever the requirement is. For backups to generators, the National Electrical Code now requires if you have a generator source that could be down for maintenance, which is pretty much any diesel engine is going to be required to go down for maintenance, you're required to be able to connect a temporary alternative source without disturbing the permanent wiring. So now the National Electrical Code requires a manual transfer switch or something along that line to be installed in that system so you can put a second generator in there. I've also done work at airports where they had two utility sources that were separate and from separate power grids so that if you lost one, you didn't lose both. I've actually done work at one airport where we had two utility grids, both separate, and then a backup generator on top of that. And then alternative to a backup generator, to take care of smoothing out the process, I just saw a prototype for a kinetic energy device, which basically the utility power comes in and drives an electric motor. That electric motor drives a generator, which powers the system. So it filters power coming in by going through this mechanics. It also has a large flywheel attached to it. So if the utility disappears, this large flywheel keeps the generator turning long enough for the engine to come up and assume the load, and you actually never lose power the whole time. So that's another energy source that's on the future, on the horizon.
We have one airport in the States here which has a large UPS backup supply that they can lose their main power and waiting to turn on the generator. They can run the whole lighting system on a UPS, believe it or not.
That's
That
excellent.
is,
I visual aids panel meeting we had in Japan in the mid-90s. We went to Narita and they'd got a, if you like, a variation of that. Certainly on the critical lighting, they went from commercial supply to battery, and from battery to the airfield distribution system. So in fact, they got a battery backup, which would take them through a period, a no-break power supply. It's using other technologies that way, but they'd actually implemented it that way, and it's one way of doing it.
internationally now, of course, the UPS, static UPS is a common feature internationally in projects, and so that the UPS can power the AGL whilst an alternative supply kicks in. For example, the standby genset. So that's a standard. But what I wanted to say on this one is perhaps the standard needs to be challenged of the 15 seconds. And I think you alluded to that, Tony. Well, is that why on earth have we got 15 seconds? Why don't we have a standard AGL supply, which is no break?
We do here. We have a 1 second requirement transfer between operating and standby.
But there isn't internationally.
I think
no, 15 seconds.
I think this is where you can have, if you like, electrical engineer designers used to making power supplies who've got no aviation operational experience and would not understand there's a difference between a no-break system, which you need if you're doing precision approaches.
Correct.
Making decisions, that must be no break. The 15 going to a standby generator is never a solution to safety. It doesn't contribute anything enough to safety. It does contribute to regularity. If your main system goes, you can run on your standby generator, but you can't do precision approaches.
Yes,
you can still maintain a service in effectively non-precision approach or VFR.
A bit late though if your lights go out.
Yeah.
And you're in the flare situation, as you previously said, Tony. That's why maybe we should be challenging the standard.
Yeah. Well,
I think we should.
Interestingly, we had an airport recently in the last 6 weeks where the lights did go, the public supply did go out, and the generator failed to start, and they had to close the airport. And this was a major international airport. One of the other aspects, of course, is you need to test your preventive maintenance regime needs to include regular testing to ensure that the performance of the generator, to meet the standards, and ideally the continuous operation standards. So that's just another thing to bear in mind.
That's where it comes to maintenance issues, huh?
Yes. So we got two questions, one of which is a huge question, but I'll ask the other question. If aerodromes implement advanced surface movement guidance and control systems, will there still be a requirement for signs?
Yeah, I can answer.
Yeah.
I'll answer that. This is where knowledge of operations and how pilots work is important. Do you need it? There's a thing in aviation which is called situational awareness. It's vital to pilots to know where they are, and that applies. And if you have failure cases, then one of the first things, where am I? If you don't know that, then it causes. I remember actually going fog flying to an airfield that was nominally closed, and we got a dispensation. We could fly in any weather. We landed landed at this airport, perfectly satisfactory, and we're on the main runway. Air traffic said, "Where are you?" We said, "We're on your runway," and they got no awareness with the information they got as to where we were. And you can see the situation where your ASM GCS A fails, or B, something makes you think you're not in the right place. You want an independent means that isn't a subset of the ASM GCS, that at least gives you the basic thing of saying, yeah, I'm on this taxiway, because the pilot will have that information in the cockpit where he should be. He knows where he should be. He can see the signs and say, yeah, that's where I am. That often could be quite a safety thing to cross check that you're and I think even if you drive on the roads these days, you may have your sat nav, but aren't you awfully glad to have the signs there as well sometimes, or the paint marks on the road to verify that the sat nav is telling you the right thing?
Thank you, Tony. So the last question, as I said, you could probably write we could have a whole episode, a whole webinar on this question, but I'll ask it, and if you can give me one thing each you think will be different. What will future infrastructure look like? What do the panelists think the future infrastructure of airports will look like? What's going to be different?
Resiliency and energy efficiency.
Series circuit, 6.6 amp circuit, and that method will disappear.
Okay.
I personally agree with Stuart there. I think, we've lived too long on the deviation of street lighting on airfield lighting, so alternative methods of visual cues will come in.
Tony?
I think in one way, the obvious impact is going to be the new light source, the LED. It's going to influence development that will come whether we like it or not. And it needs to be guided, and we could take benefits, as I tried to show. But LED is making a profound difference. One thing we haven't mentioned so far, of course, is there's no heat in LED. And there are some issues there with getting rid of ice on things. I think when LED will be the big thing, but there's some development needed yet to identify some of these issues. But we'll have gone. Somebody that perhaps visits an airfield that they worked at 40 years ago won't recognise. There'll be so many things changed because we switched to LED.
Right. Well, thank you very much to all the panelists, Keith, Seward, Carl, and especially Tony for putting together today's presentation. Thank you to Damon for arranging today's webinar, and And I'd like to leave you with one thought. I would like to reach out to all the regulators, regulatory bodies out there listening to this, and saying, I would like to see some leadership, please, in respect to these new technologies and their adoption to enhance safety and efficiency at airports. I think we need the standards moving along with the times, as we've seen from Tony's presentation. There, in a number of respects, the standards are also lagging in the last century, and there's a tremendous opportunity for us all here. But I do believe it needs the regulatory authorities to take very much of a leadership role in this respect. So, thank you very much to everybody. I really appreciate your everybody on the panel, your time and effort put into today's webinar, and of course, special thanks to all the participants, without which we wouldn't have this in the first place. So, thank you very much, and see you all in the same place at the end of on the last Tuesday of next month, and have a good month. I'll see you soon. Thank you. Bye bye.
Good
Thank you.
on.
Bye.
Thanks. Bye.